nuclear equations. So first you need to know some history of radiation. Becquerel discovered radiation. You don't need to know when, but he was the first one to discover radiation. The Curies, Marie and Pierre, discovered polonium and radium by studying uranium ores. Rutherford carried out the first nuclear chain reaction in a lab, while Roentgen discovered X-rays, and so he named them. He discovered these while working with fluorescent minerals. Fermi was the first scientist to split the atom. He also produced the first man-made element, which was neptunium. And if you remember from first year chemistry, splitting the atom is fission. Radiation is the penetrating rays and particles emitted by a radioactive source. There's three types of radiation: alpha, beta, and gamma. Alpha, the two symbols you need to know are 42He and the alpha symbol. An alpha particle is the helium nucleus. So since it's a helium nucleus, if you remember, the top is our mass and the bottom is the atomic number. So our mass is 4, and since it's just the helium nucleus, it has a charge of positive 2. Penetrating power is low. You can stop it with a piece of paper. A beta particle is a fast-moving electron. The symbols for beta are 0, -1e, and the beta symbol. Since it's a fast-moving electron, it has a charge of -1, and it has no mass. Penetrating power is medium, and you can stop it with your skin or with foil. Gamma radiation has that symbol. It's pure energy, so it has no charge and no mass. Penetrating power is high. And you can only stop it with lead or concrete. Here's a picture showing how you can shield yourself from radiation. Notice that the concrete doesn't stop the gamma radiation until midway through it, so it's got to be a thick enough piece to stop it. So alpha radiation consists of helium nuclei that have been emitted from a radioactive source. The types of equations at the bottom are transmutation equations, because it's converting one type of atom to another. These are basically addition and subtraction problems where the reaction sign is an equal sign, and so we have 208 is equal to something plus 4. And 84 is equal to something plus 2. So we get 204 and 82. The number on bottom is our atomic number, and that tells us what element we have. So 82 corresponds to lead. The bottom, something is equal to 226 plus 4. And so that's 230. And then 88 plus 2 gives us 90. And 90 is TH. Beta radiation consists of a fast-moving electron formed by the decomposition of a neutron in an atom. So a neutron breaks down into a proton, which stays in the nucleus, and an electron that is released. The mass stays the same and the atomic number increases by 1. So looking at our bottom equations, 137 is equal to something plus 137. so 0. And 56 plus something gives you 55, which is -1. 0, -1 is our beta particle, which is represented with the E. In our bottom example, 1 is equal to something plus 0, so 1. And something minus 1 is 0, which is also 1. And 1, 1 is hydrogen or a proton. Gamma radiations do not have a mass or a charge. Therefore, emissions of gamma radiation does not affect the atomic number or the mass number of an atom. Gamma radiation normally occurs with alpha or beta as well. X-rays are going to be similar to gamma rays. The only difference is their origin. X-rays are produced when excited electrons in metals lose their energy, while gamma rays are produced by unstable nucleuses. Here are some other particles that you need to know. Before you try these on your own, look at number 3. When you have a coefficient in front, you just multiply everything behind it. So that's 2 times 1 is 2, and 2 times 0 is 0. And then for number 4, just make sure that you write what an alpha particle is. Pause the video and try these on your own. Restart when you have these 4 done. So 6630 zinc, because 66 is equal to 66 plus 0, and 30 minus 1 is 29. 20482 lead, 4421 scandium, and for 4 we plugged in 4 and 2, making that 9 plus 4, 13, and 12 plus 1, 13. 4 plus 2, 6, and 0 plus 6, 6. You'll also need to be able to solve word problems. So copper 63 absorbs a neutron. Copper 63 is 6329 Cu. If it absorbs a neutron, it needs to be on the same side as what's absorbing it. And a neutron was 1, 0 in. It releases an alpha particle, so releasing the alpha particle means it's on the opposite side of the reaction arrow. And those don't total up, so it's also going to produce something else. So you do what we just did and say 63 plus 1 is 64, so 4 plus 60 equals 64, and 29 plus 0 equals 29. So 2 plus 27 equals 29. Iron 54 is bombarded with an alpha particle. Bombarded means that it has to be on the same side as what's bombarding it, because bombarding is basically hitting it. So there's our alpha particle, and so 54 plus 4 is 58, and 26 plus 2 is 28, and so we get nickel. Go ahead and pause the iPod and try these 3 on your own. Carbon 11 produces a positron, so positron should be on the products, plus boron. Bismuth 214 captures an electron, so the electron has to be on the same side as bismuth, to produce lead 214. Neptunium 237 absorbs a proton and emits gamma radiation and a beta particle to also produce 238 AM. Thorium-232 undergoes alpha, beta, beta, alpha, 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 and then alpha radiation. What is the final product for this decay series? So we're starting with thorium-232, and it's undergoing decay, so we have our arrow. And then you can count up our alpha. We have 1, 2, 3, 4, 5 alpha. So we can have the coefficient 5 alphas. Then we have 2 betas. And now it's just like the problem we had before. So pause the video and try this one on your own, restarting when you figured out what the final product is. And so your final product should have been lead 212. Because 5 times 4 is 20, plus 212 is 232, and 5 times 2 is 10, minus 2 is 8, plus 82 is 90.